Hi, welcome to my YouTube channel. This is my first video related to the calculation involved in lifting and rigging operations. So it might be very simple to you, but as we encounter many questions from the riggers for the basic calculations and our mates who are new to the industry. So let's start. So I have one very basic example. So we have four slings, and the bottom one we have 10 ton of load. Just assume it's a 10 ton of load, so 5 ton each sling is carrying on from the downward side, from the bottom side. And the spreader bar we length is 5 meter, so the each sling on the top is 5 meter each. Now we need to calculate how much the tension force on each sling. So this is our today task. So I make it very simple for the audience so that they can understand the basic concept, and the riggers who are new to the industry, or they want to learn about that one. So it's a very simple video, very simple calculation, and follow it to the end. There are two methods to calculate the sling tension. One is called the uniform method, and the second is called trigonometric method. We will discuss both methods one by one in detail. Let's start with uniform method. In this method, we have to remember the factor which is 1.4. Whenever we are using two leg sling and the angle is less than 90°, we must use the factor 1.4. So only you need to remember one figure which is 1.4. Now in this example, we have the load is 10 ton, so we will divide this 10 ton with 1.4. Always, if we have the load, then we have to divide with the 1.4. Or in the reverse situation, if we have the sling tension, let's say if we have 5 ton of sling safe working load, so if we are using two legs, so how much load we can lift? We will multiply this 5 ton with 1.4. In Now in this situation, we have the load, then we will divide. If we have the sling safe working load, we will multiply. So back to the our topic. Now this 10 ton, when we will divide, the answer will be 7.14. But as we know, there is slings 7.14 are not available in the market. So we use 8 ton of each sling is sufficient to do this job. But now the question is, how you make sure that the angle is always less than 90°? There is simple thing we need to remember. If we will keep the length of the between the lifting points and the length of the wire rope slings equal, so we will get the 60° of the angle which is best for the lifting with the two slings. Now if we don't have same sling length in this finger, like if we have the 5 ton of the length between the lifting points and the 5 meter of the slings, if we don't have the 5 meter slings, we can use 6 meter, 7 meter, but we cannot use the less than 5 meter. Then it needs to involve the calculations. So this is very simple method and easy to understand and easy to use. The second method is called trigonometric method. If we if we want to find the exact force applied on the top slings, so how we will proceed? Number one, calculate the angle between the spreader bar and the sling. Number two, calculate the forces on each wire rope sling. And number three, select the appropriate wire rope sling. Let's back to basics. So this is right angle triangle. We have this base, then we have hypotenuse, and we have perpendicular. Why we called it right angle triangle? Because one of the angle is 90-degree angle. For calculation, we need to remember one sentence, which is some people have curly brown hair through proper brushing. Why we need to remember this? Because this will help us to find the angle. Now, sine theta, sum, S for sum, S for sine. Sine theta is equal to P, P for perpendicular, and then H for have and H for hypotenuse. Cos theta is equal to base divided by hypotenuse. Then tangent theta is equal to perpendicular divided by base. Compare these two sentences, the above sentence with the lower one, and it's easy to remember about the angles. We split our task into two portions, in right and on left side. So we compare this figure with the right angle triangle. Here we have tension force, which is equal to the hypotenuse, then the perpendicular, which is the upward straight force, and we have the base, which is the half of the distance from the half of the spreader bar to the lifting point. Tension force we need to find. Perpendicular is the 5-ton upward force, and then there is the 10-ton is the total weight, so the upward straight tension will be 5-ton on each side, and the base is the half of the distance, which is as we know, we are using 5 meter of spreader bar, and if we split into two, it becomes 2.5 meter. Let's start to calculate the angle. So we have the information, the distance, which is the base is 2.5 meter, hypotenuse is our the length of this wire rope sling, which is 5 meter. Let's apply cos theta, which is equal to base divided by hypotenuse. Now putting the figures which we have, cos theta is equal to 2.5 divided by 5, we get 0.5, and for theta is equal to cos inverse of 0.5, so the theta will be 60 degree. Now the question is, why we didn't use sine theta and tan theta? Because sine theta is equal to perpendicular upon hypotenuse. We have hypotenuse, but we don't have a perpendicular. Then tangent theta is equal to perpendicular upon base. We don't have a perpendicular and we have a base. So we don't have any two information with us. That's why we are unable to use sine theta and tan theta. So we have the perpendicular, which is 5 ton, angle is 60 degree, and the tension force we need to find. Again, same for calculation, we need to remember sine theta is equal to perpendicular upon hypotenuse, cos theta is equal to base upon hypotenuse, and tangent theta is equal to perpendicular upon base. Now, sine 60 degree is equal to 5 upon hypotenuse. How it comes? Because sine theta is equal to perpendicular upon hypotenuse. As we see in our example, we have the perpendicular, which is the 5 ton. So now the hypotenuse, when we calculate, it is 5.773, which is our tension force. So we need minimum of 6 ton of wire rope sling for this lifting activity. Friends, this is our final sketch. we find the tension force and we find the angle between the spreader bar and the wire rope slings. Please don't forget to subscribe, like and share my channel. Hope you like this video. Thank you very much.